All right.
All right. So I'm gonna start all over. We've got this crate, and this is which number on the worksheet?
This is number 10, the last one.
Okay, this is number 10. Okay, read the problem to me again.
All right. So, due to friction, a force of 400 newtons is needed to drag a wooden crate across a floor. The rope tied to the crate is held at an angle of 56 degrees with the horizontal. This is part A. What force is needed to end the crate to move the crate? Like, what kind of question is that? You need to word it different or something.
Well, it's based on the idea that you understand that the force that you're pulling along the rope, that's not what's actually pulling the crate. What's pulling the crate is one of the components of this force, which is that one right there. We call this one the force horizontal. Okay?
Oh, okay.
All right, and then you have this other force where you're actually wasting some of the force trying to lift it off the ground, but you really can't do anything about that. So
all right.
kind of a wasted, kind of like heat in a gasoline engine. That's a loss of energy that we really can't do anything about. All right,
Yeah.
so we're dragging this thing, we're dragging it, and so the problem becomes, what is that horizontal force right there? And then you go to your trig functions, and which function has, see this side is the adjacent side to that angle. All right, so if it's the adjacent side, which one of the trig functions has adjacent in it?
Yeah, I don't know, honestly.
It's cosine.
Cosine.
Okay, which is cosine of theta is the formula, equals the adjacent over hypotenuse.
Okay.
Okay. Can you still see all of that?
Yes.
Okay. All right. So the hypotenuse is the one that's opposite the right angle. So here's the right angle. So the hypotenuse is the 400, the force along the rope. When they read you a problem like that, that's actually the force along the rope you're looking at.
Oh.
All right. All right. So now let's plug in the numbers. The other thing that has adjacent in it is tangent, which is the opposite over adjacent, but we don't have the opposite side. So we had to use the one with hypotenuse in it, which was the cosine. All right, so let's plug in our numbers here. Cosine, our angle is 56. Okay, our adjacent side is what we're looking for. So that's the force horizontal over our hypotenuse, which is 400 newtons. Okay, so then we're going to multiply both sides by 400, and we end up with force horizontal equals cosine of 56 times 400. Okay, yeah. So here is another formula that you can look at. It's force horizontal equals the cosine of whatever your angle is times the hypotenuse. Like that. So you can use that one if you want to. It's already set up for you.
Yeah, that seems easier.
All right. All right. So here's the formula. Do you understand how to use your calculator?
Mm-hmm. Yeah.
Okay. So down
I don't.
here, you see the cosine is in blue. I'm going to hit the second function. And then the one with cosine on it, which is Z on my calculator. And it gives me cosine, parentheses. And then we're going to plug in 56 and close the parentheses. And then we're going to multiply 400 times that. That's real important. It's real important that you have your calculator in degree mode,
Yeah.
because you won't get the same answer that I do otherwise. If it's in another mode like radians, you won't get the same answer. So here's my answer. It's 223.68 newtons. Okay, now if you were asked for the other one, then you would say, well, I need the one that has the opposite in the hypotenuse in it. And that's going to, so this is the force vertical over there. So the force vertical would equal the sine of theta times the hypotenuse. This is the already moved around formula. Okay, so that would be the sine of 56 times 400.
Okay.
Okay.
Hey, Mr. Boswell.
Hey.
Tyler just Snapchatted me and said that it says you need to let him in.
Who does?
Tyler, free.
Okay. I thought I did.
Yeah, he was in here for a second.
Okay. Back in? You there, Tyler?
Yeah, I see him.
All right.
We'd like to get famous and rich.
All right. So let's plug in, let's hit second, and then sine, and then 56, close the parentheses, and then times 400. And there's my second answer.
So wait, so like those are your answers?
Yeah.
Oh.
Is that what it says on the sheet?
No.
It doesn't say that on the sheet?
It says the answer is 715. I had to get my mom to help me, and like she got that answer, and I forgot how she got it. Like I don't know, but she like got it somehow. I'm not sure though. Wait, actually no. I think I sent. Actually, I think I do know.
Did I get 56 on the sheet that I gave you?
Mm-hmm.
Or
Yeah, the angle is 56. I'm looking at it right now.
all right. What was the answer on that sheet again?
715.
715?
Yes.
Right.
It said it's supposed to divide cosine or whatever 56 with 400. I don't.
Divide?
I think. I forgot. Like I was trying to. That's why I texted you, because I was like, because I turned it in the worksheet, not putting the answer because I didn't know how to get it. But then my mom figured it out, and I texted you that we divided cosine. Well, what's that degree?
Yeah.
Divide the cosine 56 to 400, and it gets 715.32.
All right. That's got to be a mistake. Yeah.
Probably.
Yeah.
Some answers to these are like kind of not the same. Like they're similar, but not
Yeah,
the same
similar,
answer.
that's okay, yeah.
Okay.
If they're similar, it's okay. Let me see if I've got my calculator in the right mode
All right.
after telling y'all about it. Okay, so I'm going down and it says degree right there. I do, I have it in. So that's got to be just a mistake on the answer key.
Yeah.
Are you getting the same answer I do now?
No. Well, how you did it, yes. I don't know.
Yeah.
Okay.
Yeah, this is the correct way. So if you got the same answer I did now, then you got the right answer.
Okay.
Unless you read something to me wrong. Was it 400 newtons on the rope?
Yes, sir.
Yeah.
All right, it says 400 along the rope.
It says, yeah, a force of 400 newtons. Well, no, not on the rope. Okay, it says due to friction, a force of 400 newtons is needed to drag it's needed to drag a wooden crate across the floor, and we just have to figure out the force in the crate to move the crate.
All right, what does the last part say?
It says what work is done if the crate is dragged 25 meters.
Oh, work. Okay, we're not finished with the problem yet.
No.
Okay, all right, I'm sorry.
It's
I didn't
fine.
realize. Yeah, I didn't realize there was a work for it. All right, so let's finish the problem then. All right, go back to work equals force times distance.
Right.
So we just solved for the force. We're going to plug it in there, which was 223.68.
Okay.
Yeah, you probably read it right. I just didn't listen right. All right, so
okay.
it's 25 meters.
Yes.
Okay. All right, so now we'll just multiply that first answer, 223.68 times 25. All right, and I am getting 5,592 joules.
Oh God! Wait, hold up. Is that even? Well,
No,
it's
it's
probably gonna be different. Yeah. Well, it's gonna probably be different since the part A you got a different answer. So probably definitely the second one's different answer. So yeah.
Okay. The only other thing I can figure is the way the problem's written. It may mean, no, it's got to be that way. It has to be so just change that answer. Were all the other answers okay, did you say?
Yeah. That
Okay.
was the only problem like I had. Like that problem was rough.
Okay. All right, did everybody else see where to turn in the problems? You just
Yes,
turn
sir.
it in.
you just send it back to forms. It's a forms, and you just zip it back, send it back when you get through with it by submit or something. And so then you'll be done with it. How about anything else we need help with?
That's it.
Has anybody heard from Mr.
It's a guy.
First row, I can't think of it. Potts.
Oh, Potts. I have not. I don't have him on anything.
Yeah, I haven't heard anything from him. How about Jason, or how about Medlin?
Oh, yeah, I have no. Aren't they friends? I have no idea.
Who, me and James?
Yeah,
I wouldn't say exactly friends, but no. All I know is he's working a whole bunch, like, every day.
Okay.
That's all I know.
all right. Well, if y'all come across them, tell them they need to get busy. I've sent them messages, but
When, like, do you know when this class is gonna end? Like, when's our, like, final
yeah, it's going to be
assignments and stuff?
around the first week in May. So it's not very long.
Yeah, because I'm done with my English class. So
All right,
I was
let
wondering.
me talk to you about the lab I'm going to send you. Does everybody know where your power meter is?
No.
Power
Your
meter?
electric meter? Your electric meter?
No.
What the?
You know, the thing that they read, give you a bill every month.
I mean, yeah, I know what it is, but I have no clue where it is because I'm at the meeting's house.
It should be on the side of your house. It should be on the side of your house near the front.
I'm sure I can find it.
A power meter? So
Yeah, electric
Okay.
meter.
It's a gray box with a white dial.
Yeah, and it may be dials or it may be digital now.
Okay, I'll ask my stepdad.
If
what's up.
it's digital, you're set. But if it's not, then we've got some problems. We'll have to watch a video on how to do it. I'm going to send you a handout. So this is going to be kind of a big project to get some, credit for lab. So take it seriously. And how's the COVID-19 graphs going?
Good.
Good.
They're still going up?
Mm-hmm.
A little bit, yeah.
Is it slowing down a little bit?
No.
Yeah, yeah.
Barely.
Yeah.
Well,
Yeah. So when that thing starts slowing down, things get better. When it peaks and then starts leveling out, then things are getting better. But this is an ideal project because it's a real science project that you're doing there, because there's no answer to it yet, and you'll be able to determine the answer at the same time the scientists are, because we don't know when it's going to peak. We don't know when things are going to get better, and this is what they're doing. They're watching that graph just like you are.
It's crazy.
All right, so it's a project, and the thing that's coming is a project dealing with reading your power meter every day and trying to determine which appliances you're using the most electricity with. And so it'll be a little chart that you kind of have. You can run it off and fill it in, or you can set it up in Word and just fill it in every day as you read it. That's the best way to do it. And then towards the end, we'll stop and do some analysis, and you'll get an idea of how your electricity is being used in your house. Okay.
That's cool.
Yeah, it's a pretty neat little thing, because all you have to do is walk outside and go around to the side of your house. You don't have to go downtown or anything like that. So, all right. So, is anything else I can help y'all with?
You have any questions?
No.
All right. Is 4 o'clock a good time to meet with you?
No.
No?
wait.
What's a
Yeah,
good time then? I don't even know.
I just woke up.
Yeah, sleep schedule's kind of crazy, isn't it?
Mm-hmm.
Yeah.
Yeah.
Like every
Preferably
time.
earlier.
Yeah,
went
every
to
time
bed
the
around-
sun would come up, I would sleep.
Yeah, I went to bed around 2 o'clock last night. I was watching Netflix, and so then I went right to sleep and woke up about 5 or 6 o'clock and just laid there.
Whoa. that
I'm
cannot
getting
be
up and
me.
doing some work, you know. So I got up and did some work, and then about 9 o'clock, I went back to sleep. I mean, my schedule is just crazy. Crazy.
Preferably, if we could do it earlier. I'm at work right now.
Oh, are
Oh,
you?
oh, dang.
Dang.
What would be a good time?
Mm.
Anytime before
Can't-
3 o'clock.
Can't get Michelle out of bed, evidently, but is it what? How about 5 or 6?
I work until 6:30.
Okay.
Working man.
Yep.
Well, would y'all like to do something around 7 or 7:30?
7 sounds good.
Yes.
7:30. Okay.
It's whatever y'all want to do.
All right. So that work. Anything pretty much works for me. So I will schedule the next one in a few days and see how you're doing. Make sure you understand everything. Go ahead and get that worksheet turned in to me, please. And then I might have a little quiz for you to take. And it'll be the same kind of problems, and you can use your notes to take the test. Okay?
Okay.
But I won't give you the answers.
Oh.
Dang. Okay.
Okay. Does that sound good?
Yeah, sounds good.
Yeah.
All right. Well, listen, I guess that's the end of the meeting. Thanks for coming.
Okay.
You're welcome.
Bye-bye.
Michelle, good to see you, or good not to see you. Your many
Oh.
personalities. Michelle has about 5 different personalities. We saw all of them today. Okay, take care, everybody.
You
All
too.
right. You
Okay.
All
too.
right. See ya.
Bye.
Yeah, at some point I'm going to stop. Let's see. Stop recording.